Hello everyone, myself Reenu. I'm part of Commercial Software Engineering Group, and today we are going to talk about big data and we'll see how you can process large scale data in serverless manner. So we'll go through one use case and we'll see how we had implemented uh, processing of large data using SQL, basically T-SQL. So when we talk about big data, we know it's involved a lot of data, but how much? According to IDC predictions, by 2025, world's data will grow to 175 gigabytes. So it's mean on an average, if the internet speed that we do have these days, we need to download this data. You know how many days will it take or years it will take? It will take around 1.8 million years. So that's the size of data that we do have these days. And apart from this, there are tweets that we send. It's every day there are 500 million tweet that is being sent. In similar way, there are so many examples through which we can show the data that we talk about today. It's not the small one, and it's the multiple sources from where we are getting this. And no matter how we define this data, the information, the data that is getting generated, it's in the end information that we need to convert out of that. So yeah, today we are saying it's data, but does this data impact our lives, or can we use this data to improve ourselves? Let's have a look in this diagram. I know most of you know already what this diagram talk about. Yes, this diagram is all about COVID-19 cases. This data is used by various organizations to research and develop the virus vaccination and to help us fight with this situation. And massive amount of this data is used majorly by the scientist, health worker, and other COVID warrior to help them give the relevant information so that they can decide where to start and how to resolve the specific issues and how to deal with day-to-day situations. So it's all about the data. In current situation diagram, you can see the major countries from where we are getting the most COVID cases and how this data is relevant or helping us to predict future, because we have data which is currently, which is from past, and we have relevant information like travel history, dietary requirement, medical history of the specific person, and the specific weather of their area, and tracking of a person. That's how this data is getting generated and finally it is getting converted to the information. So now we are talking about information. Let's have a look. And let's first talk about India. So COVID data that is getting generated these days, you can see the high level figures, and we will see how this data is used by one of the organization to help the human life, to help to meet our day-to-day requirements. So this is the India data. There you can see the major cities and major states that was impacted by the COVID and their GDP growth. And on bottom side, that the pie chart that you see, it is showing the personal consumption expenditure of a normal citizen of India. And the major chunk, that was the food. So now with help of this information, we'll see how best innovation can happen. And in the same direction, Government of India had run many hackathon for seeking the ideas how we can use this data, this COVID data, and we'll see how the innovator and entrepreneur can use this information and come up with a solution that can help our COVID warrior as well as the citizen, and to help them fight this COVID. And one of the solution that came, or I would say that was the most um used, was the COVID tracking. Because if you see uh, data that was majorly either how we are going to track the users, and in an earlier pie chart you could see it was, the food that was the major requirement everyone. So again, if we need to supply food to the citizens, it's going well supply chain. And apart from this, if we talk about the supply chain for the medical sector, so all the healthcare worker, they need to have proper equipment, they need to have PPE kit, they need to have medicines, they need to have other equipment to fight with the COVID and to help us. So these days we do have multiple data sets which are available as data source. So Kaggle also have a data source which is having all the list of cases, and they also publish data periodically for tracking of the COVID cases. Apart from this, specific regions like European countries, they also have a single set of data which is getting updated periodically that we can use. And also on Bing, we also have a data which is getting updated that can be used for the analysis. And that is a use case for us. And we worked with the one organization to make this happen with help of the open data that is available in the market. And this supply chain is not restricted only to the hospital, it is also for the meals delivered services, and also the essential services, which is, a kind of home delivery you can think of. Like these days you just order online and it is getting delivered to your home. Then how we are using this data to find the prediction load, and we'll see where to deploy the right resources. So we'll see this. And uh, with COVID, we can see the data that is growing. It is almost 300% per year growth as compared to the last year, only in terms of the supply chain, the kind of order that we are getting these days. So let's see how we can use this data and we can create the solution around it. So how we can help. So there are few challenges these days. So first challenge that we have is around the sharing and collaboration. So when we say we need to have a project that is focused on the supply chain, we have a lot of data coming in, we need to process it, and we need to say where is the upcoming requirement for the specific order or the specific region, that we need to have the right resources aligned to that. So we have n number of participants who are working to make this happen. So for many teams, it can be very difficult to share and collaborate on big data analytics project. And this is not because we don't have right resources. This is because we have restrictions around security, accessibility, transparency, and the data transfer issues. And this is going to be more harder in these days because now we are working on the remote teams. And these remote team need more collaboration over distance, and also it will often lead the data qualities issue. And it's well known that there is a skill shortage for the data scientist, and to close this gap, uh, it's not a one-day job, so it's going to be very difficult. Phone. So the problem is how this volume is getting increased. So with increased volume, so we need to have right resources to process this data. And can we have, do we need to purchase this right resources like for hardware or the softwares? So, and it's not like we need to have 100% allocation. Can we have something ad hoc? So through which we will just, whenever there is a requirement, we'll process the data. And once we are done with our task, we'll remove those resources. So we can be safe on the resources side. To meet all these challenges, let's create a strategy. So for the use case that we worked, what we did first, we laid down a information technology strategy for that particular customer. So we divided all the tasks into two parts. One was the demand from where it is coming. So this demand is information demand. To meet that information, how we can get it delivered. So this is the high level diagram that you can see. From the demand side, we identify the key stakeholder which was there, like who are the owner of the data, who are the stakeholder, chief data officer, information officer, IT pros, data steward, and what was their user interface, what's their UX through which we are going to access the data. Either they will access data directly from the collections, or they are going to access data from the reports, or like you can think of Power BI reports. But from where these collections or the Power BI reports will be getting the data. So in the end, data is coming from the storage, network or compute. So in between, we need to have two layers. One is to meet all the security requirements, we need to have one layer that is specific to cybersecurity. Another is our operational data or analytics data science layer. So this is the high level information strategy. I know it's not different from the other one, but we'll see how we transform this IT strategy to the actual technology implementations. To have that, we've identified there are few key components that we need to have. These are the key components. That first, data is getting ingested through the different sources, and different sources data is going to be stored in a, might be blob storage, or you can do your data storage. So we need to have that data lake kind of system in which we will push all the storage, the data which is coming from various sources. Then we need to prep and train data, and then finally we can serve data to data warehouse for the other analytics through which we can access, or we can provide access of this data to various app, and we can generate the insight. So these were very high level component, and these component were helping us to achieve our goal. So now let's talk about, now we have information technology strategies, we have identified the key component, let's implement. So the major, I'm not going to talk about the other component, but the centralized piece of our solution was the Synapse. So Synapse is our next generation Azure SQL data warehouse solution, and that is that delivers limitless analytics on demand of building and deploying rich analytics scenarios. And in this solution, uh, or in this particular session, I will focus on the specific red section, that is SQL. So we use the SQL on demand for our use case. And in a while, we'll talk about why SQL, why we are not going ahead with a Spark for the analytics runtime. So you will see how the SQL we can work on the data lake content, and we can spin or we can work on the data, and we can get the relevant information without spinning any additional Spark cluster or the Sparkware, our SQL data warehouse. And uh, so let's talk about why the SQL on demand, why we selected out of this full blown solution, that is Synapse for our data warehouse, why the specific SQL. So they were to use SQL on demand. Basically, there are three major use cases or scenarios that you can think on, in which this serverless, in other word that we say, that fit into. One is if we need to have a quick view of the data that is coming in the various format, like Fargate or CSV or JSON format, which is getting ingested into data lake. So how we can extract the insight out of it. So this is the basic discovery. We are not going to talk about the complicated function that we need to apply. This is a basic discovery. And another scenario is like, by putting this T-SQL view on top of the data in our data lake, it will make end user to query like they are doing on the SQL or the relational database. So no additional skill set are required. So the customer where we were working, their requirement just they wanted to see where the highest number of cases coming in, and they wanted to have a direct connector to the open source uh, data set that is published by various authorized agencies like WHO and Kaggle, and also we do have Bing. So they want you to use one of the data source, and they wanted to have the basic layer of insight of the data, and on top of that, since they did not had a big team of data scientists, they wanted to have a look, can we use the SQL queries, or the we have a lot of SQL developers, can we use their skill set to execute this project through which we can enhance our supply chain workflows. And also they wanted to see, can they do the data transformation with simple, scalable, and proficient way, and where data is getting stored into data lake, and through which they wanted to have Power BI reports generated, and also they wanted to have some pipelines embedded, so through which they wanted to copy data from various sources and convert that to uh, in SQL viewable file. And that's why looking at these three, like uh, basic insight of the data and skill set that they were expecting to match to SQL, and how they can easily transform the data, they wanted to go ahead with the SQL on demand. Now SQL is fine, but why serverless? So serverless, reason being, they don't want they wanted to execute these queries, their procedures only once in a day. They don't want to hold the complete infrastructure to saving on the infrastructure side cost. So they had that budget requirement. That's why what they did, let's have work on the serverless side with the SQL and achieve our goal. To have this, in a while we'll go through the demo. I hope you can see my screen. There you can see there, as I was telling you, we were using the open source dataset which is currently available. Uh, so we focused on Bing dataset as well as on the European country dataset. And let me first show you the data that it was we were looking at. So for the European country data, what we did, we were just looking to identify so like where the highest number of cases coming, and what's the spike, and the high hiccups that we were getting, so that we can give the relevant information to our branch offices which is there to manage the resources. So so first we did a query on the European dataset. There we wanted to get a list of the countries, and we had a centralized hub that was in Italy. So first I wanted to get the geo ID of the Italy, so that is IT. So I will run this query, and there you can see it will return all the geo IDs and countries which is having like IT in it. And as I said, this is on the European countryside. Then you can see all the countries which is having IT in it. It got listed, and for Italy, yeah, this is my geocode IT. And so what I will do next is I need to track the cases which is there in the Italy by the date, and based on that our data scientist will do the further analysis and will predict the upcoming load. For that, as I got the GeoID IT, and this is my data set. And the interesting thing is, now you can see I'm directly reading data from a file. This is my forget file from which I'm dating, and for that I'm using the open row set. This is a function through which I can do the bulk data read. Although you can do, data read from other formats also, like CSV, JSON. But why I'm going to use the forget file is because its performance improved. So I was getting data from other various sources as well. So what I did, I converted this data to this all the CSV JSON data to the forget file system, so that it will take less resources to get processed. And now I'm going to get all the cases by the dates. So I run this query, and there you can see by dates I'm getting all the data. And this is, you can see this starting from the 31st of December 2019, and it's having rest of the dates. Now let me plot a graph so that you can get the relevant information. So now I will say, you can see this graph. Okay, now the category graph, I want to get data by the categories, that's the date. And if you remember, in month of June, July, April, May, we had a spike in Italy. Now it's again a spike. So that you can see the number, this you show the graph, how the data is getting changed. Now I can extract the date-wise information through which I can predict, I can feed this data to our data scientist, and they can do rest of the processing. And we have supply chain. We had designed a supply chain module which was using this data, and we had inbuilt prediction models. Um, those were calculating the upcoming spikes, and based on which um, we will try to calculate the next 7 days data, and we were sending this data to our Italy team to um, you know manage the resourcing side. So this is how we were sending the country wise data. But we had another requirement for the, like, country in India, in which it's a big country. We have multiple states, and each cities also have multiple specific segment, and these days we are having a lot of cases. So for that, what we try to do, we also combine the Bing data. So in Bing, we also getting the COVID data set. I'll show you from where you can get it. And then what we did, so first we try to pull all the data of the India that you can see. This is the all the data of India. You have multiple columns, like what is the country region, admin region, and admin region 2 for the specific location in it. And then what we did, this is the all India data. We tried to get it by states. So then we had put a filter for the distinct state for which it was capturing the data. And what we did, we identify a few discrepancy, and we clean the data. And then we tried to get data by each and every specific region. Like, I'm in India, Delhi. So I want you to see how many cases per day we are having in Delhi. And also in Delhi, we have different specific segments. So positive point of Bing data was we were getting sub-region data as well. So we also put this additional filter for South Delhi, and this is the data that we got, like how many confirmed cases, and per day how many data is getting changed these days. So this is the data we find out, and again we plotted the chart out of it, and we did prediction model, and finally we feed this data to this data scientist team. So key point here is not how you are going to run the query. So first is like format. You can see this is like SQL data format, and how on the resourcing side you can see I'm connecting to built-in. And if I will go to my monitor, there you can see how many requests I have made, and these are all via the pool that is built in. And what is this built-in is? This built-in is my serverless type. So it's not like my resources are spinning continuous, I'm getting the bill. It's whenever I'm going to fire this query, it will spin up resources for me, and then it will release. So currently, because I have just fired the query, you can status the online, and it will auto scale down based on my requirement. And once I have less requirement, it will auto shut down. So So as I stated earlier, so we had key requirement. One was we had to manage the bill. Another is we had lot of SQL developer. We wanted to utilize their skill set to pass the data that you could see. Through our queries we were able to achieve this, and again we were able to work in a collaborative way. This is the SQL script which I show you. In similar way, you can have your Jupyter notebooks that you can create, like SQL scripts that you can create, through which we were doing this. And apart from this, what we did, we designed few data pipelines through which we were able to push other relevant data like travel history of a person and current location. So through which we were getting order, and we'll see what's the whether it is in red zone, green zone, and based on which we could see the security requirement of the specific region, and that's how we were managing our resources. So those were defined in the data pipeline. So this is overall how we achieve that goal using SQL on demand. And let's have a look on the best practices side. So what are the best practices if you need to have implement similar kind of solution in your area or in your domain, how you can achieve this? Now let's talk about the best practices. So now you have already seen how it is working using the SQL on demand in serverless manner, how we have achieved supply chain requirement using the COVID data. Now, what are the best practices around it? How we can achieve the best performance? First is, if you are going to have multiple CSV file or JSON file, you need to convert this to per get file. So basically these file format are columnar format. So when you are going to run a SQL kind of queries, or I would say SQL-less, serverless SQL pools, it will be easy uh, for the processor to take and process in within the less time and fewer storage requests to read in and out. And another is, if your SQL targets a single large file, then what I would recommend is just split your data into multiple smaller files so that it is easy to process. And recommended file size is always less than the 10 GB. So if you are having multiple file, then just try to break it down to the smaller one so that it's easy to process. And in demo, you have seen that we were using open row set to process our queries. So that's why it's better to have equal file sized for a single open row set path for the external table location. That they were like, I also showed you the Bing path or the European data set. So just try to have a file with an equal size. And then let's push wildcard because how you are going to access the data. So I always recommend to push wildcard to the lower level of the data so that it take less resources and using less storage API calls to process that. And apart from this, there are a few other best practices that you can use. Like the one is CTAS. This is the most important feature available in serverless SQL pool. And this is the parallel operation that create external tables metadata. And it helps you to identify the data types and so that you can plan next step accordingly. And it's easy for the joins and other operations. So these are the few best practices you can implement in your project while you are going to use the SQL on demand in serverless manner. So this is all about today's session. Thank you for joining us and have a good day ahead and enjoy other sessions. Thank you.